Welcome to the webcast, Hybrid Vehicles and Safe Repairs, presented by Jeff Poole, iCar Performance Training Coordinator, and moderated by Bruce Adams, Managing Editor of ABRN. This webcast will help you understand how hybrid vehicles work and give you some tips on how to repair them properly and safely. First off, we'd like to thank our sponsor, Mitchell International, for their support in bringing this webcast to you free of charge. A lot of people are wondering if hybrid vehicles are a passing fad, maybe something they can just ignore and wait out until they go away. These people would be making a grave business mistake, because all signs indicate that hybrid vehicles are part of an evolution of transportation that is taking place. As hybrid technology continues to improve, future hybrid vehicles will be based on and advanced from the current crop of hybrids. Jeff, can you talk a little bit about hybrids, how hybrids have been increasing in popularity during the past 10 years?
Sure, Bruce. Over the past 10 years, we've seen a continual rise in the popularity of hybrid vehicles. I think back to the first vehicle that came into a shop that I was working at, and I believe it was a Toyota Prius, and we were doing some rather minor repairs to it, and there wasn't really a lot of apprehension about the repairs to the vehicle or concerns about it, but there was still that stigma of it was different, and we needed to treat it different. So we had our kid gloves on, and we went at it diligently. We look back, and a lot of the technology has evolved from what started back in the 1800s as the electric carriage. They preceded the internal combustion engine. Around the turn of the century, in the early 1900s, electric vehicles actually outnumbered internal combustion engine vehicles. There were actually a tremendous number of hybrids back in that time. But as the petroleum fuels became so affordable, distribution became rather readily available. Of course, the technology seemed to fade away. Then in the 80s and 90s, we saw a resurgence with the development of production electric vehicles. These were costly, and they really offered limited performance at the time, so they kind of faded away. But it really implanted the roots there of what we're seeing today.
Thanks, Jeff. At this point, we'd like to ask our audience to participate in a polling question. We'd like to get some idea of how many people are working on hybrids out there right now. How many hybrid vehicles per month does your shop work on? Is it 0, 1 to 5, 6 to 10, 11 to 15, or more than 15 per month? Once again, the question is, how many hybrid vehicles per month does your shop work on? 0, 1 to 5, 6 to 10, 11 to 15, or more than 15. And we see that more than 90%, 30% was 0, and 60% 1 to 5. So the vast majority, 90%, slightly over 90%, are either doing 5 or fewer at this point. Thank you for polling in. Now I would like to ask a follow-up question to that. Does your shop sub out any hybrid repair work? Once again, the question is, does your shop sub out any hybrid repair work? And please select, yes, we sub out electrical. Yes, we sub out mechanical. Yes, we sub out both electrical and mechanical. No, we don't sub out any hybrid repair work. Does your shop sub out any hybrid repair work? Yes, electrical. Yes, mechanical. Yes, both electrical and mechanical. Or no, we don't. 56% does not sub out any hybrid repair work. Approximately 28% sub out both electrical and mechanical. And it's interesting to see where people are falling in this realm today. Thanks once again for polling in. Jeff, can you discuss some of the differences between the electric vehicles and hybrids?
It's important that we have an understanding of the technologies that are in these vehicles, so we'll first take a look at electric vehicles. Electric vehicles were propelled by an electric motor, and powered by batteries, which, of course, when the batteries run down, you better find a charging location. Otherwise, things aren't going to be looking too good. So we really have to take and plan the use of that electric vehicle around the capabilities of that electric vehicle. Our hybrid vehicles, of course, combined the electric vehicle components with an internal combustion engine. And we're going to refer to that internal combustion engine as an ICE, like an ice cube. So the ICE gives us the driving freedom we enjoy. Hybrid vehicles are more appealing. You have the internal combustion engine, which provides power, can generate electricity, provide propulsion, depending on the design of the vehicle. And so we get the range that we're looking for. We get that freedom. As long as we have fuel in the tank, we don't have to be concerned about the state of charge of the battery. We've seen a few hybrid vehicles with plug-in charging capability, which we're seeing a little bit more popularity of that as we move forward. This allows the vehicle owner to take and plug that vehicle in, the vehicle user to plug that vehicle in, and recharge the onboard battery packs so that they can get that more efficient energy, a little more cost-effective over generating that electricity using petroleum fuels.
Great. So tell me, why do you think the electric vehicles are gaining momentum?
The electric vehicles that we're seeing today, and the hybrids for that matter as well, we've got pretty impressive performance levels coming out of these vehicles. You know, I look at a Toyota Prius, and to hop in one of those vehicles and drive it, it's a pretty peppy little vehicle. So, the electric vehicles out there that we're seeing, they're on par with some of the top performance exotic cars that we have that are gasoline powered, so far as some of the performance electrics and their acceleration arena and overall performance numbers, pretty impressive. So we couple the refinements in component design, battery technologies, the capabilities of the vehicle, increasing consumer awareness of environmental concerns, and a continued desire to be less dependent on petroleum. We pretty much arrive where we are today, and hopefully this is going to continue on into the future so that our children have better modes of transportation.
And this next slide shows a small sampling, if you will, of some of the electric vehicles out there.
Yeah, I enjoy sometimes whenever I'm traveling around different market areas to see some of the vehicles that are on the streets. And recently I was out in Palm Springs, California, where saw a number of neighborhood vehicles roaming the streets out there in the city, doing various deliveries and things of that nature. And thought, well, I don't see those in my neighborhood, but ideal for that particular market area. From some of the smaller neighborhood vehicles to some of the higher performance highway vehicles, they're coming. They're starting to pop up on roads in our neighborhoods, and that means eventually they're going to show up in our shops as well. So hopefully we're going to be ready for them.
And I think one of the hybrid vehicles we're hearing a lot about today is the Chevrolet Volt.
Yeah, the Chevrolet Volt is really a cutting-edge production technology vehicle. I believe it made Automobile that won top awards from Automobile magazine, and it's an extended range electric vehicle, which basically means it's an electric vehicle platform, but it has an onboard generator set. And this is a really cool combination in that I can drive it electric for 30 or 40 miles depending on the driving conditions, and then I don't have to worry about the batteries draining and me having to pull over and find a charging station, because that onboard gasoline generator, it's going to fire up and it's going to provide the power to charge the batteries and propel the vehicle so I can continue to run as long as I've got fuel in the tank. Definitely an interesting combination, and hopefully something we're going to see more of in the future. I'm real hopeful that they have great success with that.
Jeff, could you explain the difference between mild or full hybrid vehicles?
Yeah, that's a pretty straightforward one. Whenever I think of, and I look at Honda, all of your Honda hybrids that are out there are what we call mild hybrids. What that means is they are propelled by the internal combustion engine, and the electric motor technology that's on board provides assist during acceleration and other driving conditions. And then when we're slowing down, it also allows them to recapture what we call the kinetic energy of the vehicle through regenerative braking and recharge the battery a little bit as we slow the vehicle down. So mild hybrids will always be propelled by the gasoline engine, and the electric technologies assist. Whereas the full hybrids, and your Toyotas and your Fords are typical of your full hybrids that are out there. these vehicles are capable of electric-only propulsion at low speeds for a limited distance. It really varies with the make and model and some of the different features of the vehicle as to what the range is and things of that nature. But your Ford and Toyotas are good examples of vehicles that are full hybrids, electric-only at low speed for a limited distance. Then the gasoline engine will kick in when it's needed and provide propulsion, generate electricity, et cetera, to keep that vehicle moving.
One of the challenges that repairers face today is the complexity of electronic modules in the hybrids, and that vehicle-specific training is required for them.
Yeah, some of the folks that know me know that during some of my presentations, I step back a few years and I think about the most complicated thing that was in the 72 Nova, which was the 8-track player. Some of you can sympathize with that, maybe not. But ultimately, whenever we think about the technologies in today's vehicles and to look at the evolution of technology, I've always been kind of a technology junkie at heart. I like to know what's going on. I like to know how it works. Keeping up with the technology, it is a very, very challenging task for us as an industry. I look at the service industry, the automotive service industry at the dealership service department level. In many cases, we've got technicians in there that specialize on particular vehicles because of the complexities of these systems. And for us in the collision repair industry, where we typically like to get a vehicle in, we like to follow that repair through from start to finish. And in a lot of cases, as we saw in some of the polls, we don't like to sublet out some of the work, but might come down to a time when we have to because we don't have that diagnostic capability. It takes that specialized training. It takes that specialized test equipment. It takes the correct information resources in order to facilitate the diagnostics on that vehicle. And that is a big, big challenge that we have in the industry today.
And just like in the real estate, location can be very important in hybrid vehicle repair technology.
Yeah, that's one of the things I do as I walk up to any vehicle today, and I'm looking at collision damage. I'm assessing, okay, what type of vehicle is this? What type of unique technologies are on board? And where are they located? And what was the susceptibility to damage in that particular collision? That way, I'm respectful of what's there, and I'm safe about what I'm doing. That doesn't really stop me from really diving in and taking it apart because I'm pretty bold in that manner. But I'm always respectful of the fact that whenever I'm working with one of these vehicles, there are potentially voltage levels there that can be detrimental to my health. And I don't need a whole lot more excitement than I have already in life.
Can you tell us a little bit about the battery technology that's behind the hybrids?
Predominantly, in today's production hybrids, we have nickel metal hydride battery technology. They're the current leader in what we've got out there on the roads right now. That might change here in the pretty near future. I believe it's already starting to happen. The nickel metal hydride batteries have proven themselves as they've got a real good track record, but their energy storage capability per pound, if you will, is not up there where we would like it to be. And that's where the vehicle manufacturers are looking at the lithium battery technologies, and we're starting to see those slowly incorporate and make their way into these vehicles. I mean, the Chevy Volt is a real good example of where they've gone with the lithium battery technology because the energy density of that battery is so much better than the nickel metal hydride. Typically, what we've got inside of a battery pack that we've got on one of these vehicles is a very large number of low voltage cells, all placed in series that add up to a considerable voltage level. Hence the safety concerns associated with the technology and the considerable energy that they can then use to propel that vehicle.
And Jeff, the battery modules themselves can be susceptible to damage from the collision, especially in the case of a hit involving the rear end.
Most of the hybrid vehicles have the high voltage battery packs located in areas that are usually not real susceptible to damage in most collision scenarios. We have seen some severe collision damage to vehicles out there where the batteries do get damaged. Again, most cases these vehicles end up being total losses, but not always. So with the photo that we're looking at right here is a Ford Escape. It says it on the screen. It's the battery out of the Ford Escape. This one was hitting the rear end pretty hard. It got hit in the rear end hard enough that it drove the rear body panel in, and it actually started to damage the battery case. And in this particular situation, the battery case was damaged electrically. The battery did not lose its integrity. It was not a safety issue. It was not a safety hazard. It was just really physical damage to the battery case. In this particular case, the components, the parts that would have been needed, aren't serviced separately from the battery module. So the battery module here was replaced as a unit assembly. Inside of this battery, just so you know what you're looking at, the top left photo, you're looking inside the rear compartment with the hatch open on a Ford Escape. The photo to the right of that is the battery out and on the floor. It weighs about 180 pounds. And the photo underneath of that is actually the battery opened up. I opened the battery up, and it reveals 250 size D. Is about what they look like. It's about size D batteries. These are nickel metal hydride cells, 1.2 volts each, which gives us about 300 volts inside of that Ford Escape pack.
Batteries are sensitive to temperature extremes, and they can be damaged beyond repair during the repair itself. What are safe temperature ranges, and is the paint booth a danger zone for hybrid batteries? One of my hobbies on the side is radio control helicopters and airplanes, and I've gone green with a lot of my hobbies. I've gone to electric helicopters and some electric airplanes because they're quiet and they're more friendly to the neighborhoods where I go down to a park or something and fly them. I've learned through the use of the lithium batteries that they're kind of sensitive. Now, the nickel metal hydride batteries are kind of sensitive as well. So what we look at here with especially the nickel metal hydride batteries that are out there in our production vehicles right now, we find that vehicle manufacturers have different guidelines for the batteries in booth type scenarios. We can leave them in. We can leave the battery in the vehicle and put it in the booth. We just want to make sure that that battery temperature doesn't hit 140 degrees. Now, for most of us, that means realistically probably putting your booth temperature at 140 because that guarantees the battery temperature is never going to hit 140 inside of that booth. Some vehicle manufacturers do allow you to take the booth temperature to 150. It's an area where you want to make sure you're practicing safe procedures. I do recommend checking with the vehicle manufacturer for their specific recommendations and making sure you dial that booth in so you don't exceed that temperature. If you do exceed the temperature and you cook the batteries, basically what happens is internally you damage the chemistry. So that battery loses performance, and then we've got some issues that we really don't want to have. Let's talk about the 500-pound gorilla in the room, the safety of the repair technician working on a hybrid vehicle.
Absolutely. The sparks on the screen, these are fireworks that we probably don't want to see in our shop. We probably don't want to see anywhere around our business. But the reality is if you get your tools in the wrong place or you get wires shorted out and things of that nature, potentially we could have some interesting excitement that we don't want. So we're going to look at some real basic safety considerations. Jewelry, watches, rings, some of that, some of the common sense things. Let's take them off and stow them safely so that that eliminates any issues we have with that type of item. Some basics about electrical theory. We're going to talk about voltage here for just a minute. Voltage is electrical pressure. Now that's measured in volts. Current is the rate of charge flow, the amount of current flowing through a given circuit, and we measure that in amps. And then resistance is how much opposition a material has to the flow of current going through it. So we think of copper wire, typically whenever we think of a conductor, copper wire. That's a good conductor. Question for you, is your body a conductor? Most of us already know the answer to that. Absolutely. Your body is a conductor. It's not the greatest conductor, but if you put it in a circuit with enough voltage, current will flow through it. If you were to take a AA battery, little old AA, just a regular battery, and hold it between your two pointy fingers, one on each hand on each terminal, current would flow across your body, across your chest. That little AA battery is not going to do any harm to you. But if you put enough of those AA batteries in series, you'll get a little tingle that maybe you don't want. And so I don't recommend you do that. Don't want anybody calling up with lawsuits or anything like that. So let's play safe. If we're going to experiment with the AA battery, you'll actually have a few microamps flowing through your body. You push that voltage up from 1.5 volts, though, to 200, 300 volts. Potentially there you can drive enough current to injure or kill.
It also seems that proper gloves have never been more important to collision repairs than when they are working on hybrids. Jeff, could you talk a little bit about this?
I'll ask folks out there in the industry just briefly, and this is an area that we wear various gloves in our body shop, paint department, and whenever we're there working on a vehicle, putting a panel on or something like that, maybe we're wearing some gloves to protect ourselves from sharp edges. and especially if you're working around chemicals, if the gloves you're wearing are melting on your hands, we know we've got an issue with the glove. It's not the right glove for the application. Whenever it comes to these particular gloves, the lineman's gloves, that's what we're going to talk about here. This is something I look at as a very important tool to take and help protect your health, because the idea of doing the touch test to find out if there's electricity present is not a real solid test that you want to take and utilize. So we want to make sure we've got a good pair of lineman's gloves. These are going to be rated to 1,000 volts DC. They're class 0 lineman's gloves. We also recommend you have a set of leather protectors for those lineman's gloves. The upper left-hand picture, the orange gloves are the lineman's gloves, and then there's leather protectors over top of it. Do not use leather gloves that have been used for anything else. If there's something sharp in that leather glove and it punctures the lineman's glove, that makes a path that potentially current can flow through. And we'll talk a little bit about testing the gloves here in just a minute.
One rule of thumb, I believe, is that if air can get out, electricity can get in.
Yeah, this is something that we don't want to find this out the hard way, that our gloves are compromised. So this is what we call an air pressure test, where we take and we kind of roll the glove up from the cuff towards the fingertips, and we want to see that glove pressurizes. There's no punctures or tears or anything of that nature. We don't have a fix-it kit for the gloves. Once they're compromised, they're done. It's also very important that we understand these gloves should be tested on a regular basis. So OSHA actually has regulations and guidelines that take and govern the gloves and their testing period and things of that nature. Again, this is something that's critical, and to find out the hard way could be a very drastic mistake.
Here's a few basics that repairers need to have before they can get started repairing hybrid vehicles.
Yeah, sometimes we are challenged to justify investing in certain equipment and perhaps information resources that we need to do a job right. And I kind of equate a lot of what we do in the collision repair industry to being a doctor. And I think about the doctors that have worked on me over the years, and those of you that know me, I've seen a few. Ultimately, I'm very fortunate that they made some good decisions along the way, that hopefully they had the best equipment along the way. And as we look at today's vehicles and the technologies, it's critical that we have good quality test equipment, a good quality DVOM. This is a piece of test equipment that you're going to trust your life to whenever you're in there taking voltage measurements, and then you're going to say, okay, this meter's telling me there's no voltage present. Have I read the meter properly? It's going to be critical you know how to read that meter. It's going to be critical that the interpretation is correct. That way you know you can proceed safely. Whenever we look at things like fire extinguishers, that's for when you're having a really bad day. Hopefully none of you ever have a really bad day and need that. Caution signs. Some vehicle manufacturers even recommend you take and quarantine the vehicle whenever you're working on one of these vehicles that has a high voltage system, so that folks don't wander up to the vehicle accidentally. That and electrical tape is something that's for doing some temporary repairs on damaged cables, or maybe you've got some things taken loose and you want to wrap them up to keep any dirt and things from getting on them. It's not for doing any permanent repairs, though.
Do repairers need to wear a protective suit if they encounter electrolytes leaking from damaged batteries?
I always enjoy this slide, and this comes from ICAR's ALTO1 course. And this is something that, we don't know. Some of the things that we've done in this industry and some of the chemicals we've been exposed to over the years, and I'm hopeful all of y'all wear your personal protective equipment whenever you're doing whatever your job is that perhaps exposes you to anything that's harmful. It's very unlikely that collision damage is going to violate the high voltage battery modules in these vehicles. Now, that being said, there's always the possibility that it might happen. So you get that collision that somehow or another it did damage the battery. It actually managed to break the cell open. The electrolyte that's in the nickel metal hydride batteries is not liquidy like water. So it's not like it's going to run all over the place, but potentially it's going to ooze out if the vehicle gets hit that hard that it starts to compress the cells. If that were the case, then we should absolutely look at wearing our personal protective equipment. That way we're better safe than sorry. Ultimately, the electrolyte from nickel metal hydride batteries can be neutralized with a boric acid solution.
Jeff, can you talk a little bit about safety disconnect switches in hybrid and electric vehicles?
The design and engineering of these vehicles is fantastic. I've spent some time looking over some of the wiring diagrams, electrical schematics, and things of that nature because I'm just kind of a technical junkie that way. And somehow or another I can stay up late and look at that stuff, and it really helps me to understand the lengths they've gone through in the design and engineering so that these vehicles are safe for us to drive. They're safe for us to go out and wreck. And in most cases, if we follow the right service procedures and we have our protective equipment, they're safe for us to work on. So the vehicle manufacturers have incorporated in the electrics and the hybrids safety disconnects which provide additional levels of safety when working on these vehicles. Now, in certain cases, minor body repairs may not require the implementation of the high voltage disconnect use. But I have to put in the disclaimer, check with the vehicle manufacturer specific information for the make, model, and year vehicle you're working on. I have to throw that in there. So if we're doing more involved work, it's definitely prudent to exercise the correct safety measures. Typically what happens whenever we shut a vehicle down and we're trying to disable the high voltage system, when we turn the key off, typically that shuts down the 12-volt system. All the computers in the vehicle operate off the 12-volt system. Now, once the 12-volt system shuts down, typically that 12-volt system is what controls the high voltage system. So once the 12-volt system shut down, the high voltage system is shut down. So with that in mind, we can take and turn the key off. We'll disconnect the 12-volt battery, and then we'll follow the service procedures for pulling the safety disconnect if that's required for the service work that we're doing on the vehicle. That's a very generalized procedure I just mapped out. And again, I have to reinforce that. We check the specific vehicle make, model, and year information that's current for that vehicle whenever you're doing any type of procedure like this, because in some cases there may be a little twist. They may have their own little flair on how they want it done and what needs to be done at what step. So very, very important. We check with that.
And needless to say, one size does not fit all.
Yeah, the smart keys are an interesting animal out there, and we're seeing those on even some of the non-hybrid vehicles that we have. I was talking with a hybrid vehicle owner, it's been some time back, who has a mudroom off of his garage. And he was driving a Prius that he had relatively recently purchased at the time, and he hadn't necessarily reviewed the owner's manual all the way. So he pulls into his garage, parks the car, takes the keys, hangs them in the mudroom, which is right off of the garage, and he goes into his office, and he's doing some work. A little while later, he hears a humming sound coming from the garage, and sure enough, the car started itself up because it wanted to warm up. He hadn't shut it down properly. It wasn't going anywhere. It wasn't hurting anything, well, other than the fact that if it ran long enough, perhaps there would be an issue with his ventilation system in his house. But it's critical that we take and we deactivate the vehicle so we know it's not going to try to start or run while we're working on it. And that's pretty straightforward. Most of the vehicles with a smart key, they do have a deactivation switch. There may be other disarming procedures. Perhaps they'll just have you take and disconnect the 12-volt battery. Again, really varies from vehicle to vehicle. Now, looking at the work being performed on the vehicle, I mentioned before minor repairs may not require removal of the plug or the switch. You really need to ask yourself a couple of questions in this arena. Whenever we come down to this, have you read through the OEM service recommendations? Am I going to be working on or close to the high voltage systems? And I always wanted to say this one, do you feel lucky? Got to ask yourself that question. I don't. I don't take a chance. I'm going to take and I'm going to make sure I follow the prudent safety precautions. Again, you really need to evaluate what you're doing, and if you can do it safely, this is not an area you want to roll the dice on.
What can repairers learn from the color of certain cables?
The battery cables that we see typically associated with the 12-volt system in our vehicles, generally we see the black and the red cables. When we take a look at the picture on the upper left, that's what we see. Now, the picture on the upper right is Saturn Vue. We have a blue cable coming off of the battery in the back of a Saturn Vue hybrid, which is a 36-volt system. The potential for shock or electrocution from a 36-volt system is very, very low. But nonetheless, I can't say never, As a technician, I got shocked by a 12-volt battery one time. It was summertime, and I was just sweating bullets, and I was listening to a squeaky belt under the hood, and I laid my arm across the battery terminals, and it just was just enough to send a little tingle through my forearm that gave me that knee-jerk reaction, and, of course, my fist whips up and smacks me in the eye. Great fun there. Hopefully none of y'all have ever been down that road, but what the heck. So 36 volts, relatively low potential. Now we move down to the next picture on the lower left where we see the kind of yellow cables. Typically we associate any yellow wiring with airbag wiring. In this particular case, though, we're looking at a Toyota product where they've got the yellow wires going down to the electric power steering. And these systems may be anywhere from 27 to 42 volts. And we'll see those yellow cables on the Toyotas. And then we move over to the orange cables. And I think about the orange cables just like I think about an extension cord I've got plugged in out in the garage. I think, well, I don't really want to chew through it with my teeth. I don't want to cut through it while it's plugged in. Don't want to cut through it at all. And so I'm going to have respect for that. And that's where we start to see the higher voltage levels that definitely become potentially lethal.
Are there any repair procedures for the high voltage cables?
At this point in time, there are currently no repair procedures that we're aware of. The current recommendations are for any of these cables to replace any damaged cables. These are susceptible to damage depending on the circumstances surrounding the loss. Running over something in the road, going off the road, over a curb, over a guardrail, etc. They're reasonably well protected, but they're definitely not impervious to damage. So this is an area where whether it's under the vehicle or up in the engine compartment, some vehicles, these cables are a little more susceptible whenever a vehicle gets runs into something and lays the core support and the radiator back into the drivetrain components. We could potentially have some damage there. So we need to be respectful. Whenever we take and we start to open the hoods on these vehicles, we start looking at the upper left-hand picture. There's a real good example of where, if you're opening the hood and you're sticking a pry bar back in there and you're not sure what's back there, that's really not a good idea. So hopefully we're going to exercise some caution there, and we're not going to go off the deep end and endanger ourselves.
Even when the hybrid vehicle is shut down, some components may store high voltage that can be shocking or even deadly. So how do repairers deal with this?
High voltage is always going to be present in the high voltage battery pack, and it may also exist in other components in these vehicles. And this is where we just need to have that respect. No different than the outlets on the wall in your home or business. You're not going to go over there and stick paper clips in or stick your fingers in there. At least I'm hoping you're not. Perhaps something I did when I was younger, but we won't go back there. Ultimately, this is an area where having an understanding and respect of the components, knowing how to work around these vehicles, again, following the correct procedures for that vehicle, are going to keep you safe. Some of these components may have the capability of storing a potentially lethal charge for 5 to 10 minutes, possibly even longer. So this is where we really want to be respectful of these components and systems, even after we have them powered down.
We all know that gloves can be awkward to work with, but your advice, I think, is don't take them off until you know you don't need the protection they provide.
Yeah, I'd like to say better to continue wearing them to a point where you're 110% confident you're not going to be exposed to high voltage. Again, I go back to that good quality digital voltometer that I trust my life to whenever I'm then testing for power before I take those awkward, clumsy gloves off because I don't want to wear them. And then I stop and I think about my 12-year-old son, and I think, maybe I'll just continue to wear the gloves. It'd be a better day that way. So don't do a touch test. We don't recommend that.
Jeff, can you talk a little bit about torque and about reassembly?
Sure. I think back over the years again, and I think of a couple times I've left tools in a customer's car. and in one case, there was a vehicle I'd put a quarter panel on, and I left a pair of cutters down in the floor extension. And a couple years later, that same vehicle came back, and lo and behold, I was putting the same quarter panel back on the vehicle, and lo and behold, I found my cutters. And I thought, how lucky could you be? I think about these systems, though, and these technologies. And, whenever we start to take things apart, we tend to be a pretty adventuresome industry. We tend to take and perhaps sometimes get a couple steps ahead of ourselves. We really want to try to slow ourselves down a little bit, pace ourselves with this, and equip ourselves with the right tools and information. When we're putting these vehicles back together, it's going to be critical that we take and we torque connections that need to be torqued. Some of these components that you're reattaching the cables to and some of the other items to, if we take and we break something off, we're going to have some challenges there getting parts that they don't service, perhaps. At the same time, over-torquing or under-torquing connections can potentially lead to premature failures of those connections while in service. That could be potentially devastating to the performance and safety of the vehicle. So something else I look at is, like a doctor, we want to make sure that we've got an inventory of our tools and equipment so that whenever Jeff's done putting the vehicle back together, I'm Jeff, when Jeff's done getting done putting the vehicle back together, he knows where all his tools are. We don't have a stray extension down there inside of that module floating around that we hit a bump and it shorts something out while the customer's going down the road. I know it's very unlikely to happen, but good housekeeping here is extremely important.
Electric power steering systems on hybrids can be challenging when it comes to analyzing damage.
Yeah, we're seeing electric power steerings on all of our hybrids and hybrid electric vehicles out there, and we're also seeing them on quite a few non-hybrids. This has been going on for quite some time because of the potential fuel economy savings that these electric power steerings offer and afford. What we find is some vehicle manufacturers do have very specific inspection procedures, which may require the implementation of a scan tool. Again, another area we need to take a look at early in the damage analysis process versus getting it over to the wheel alignment shop and then they're saying, oh, well, we've got a problem and we don't have the equipment to diagnose what the issue is with the power steering or whatever the situation happens to be. We just need to ask ourselves those questions early on and then determine if we have the right information, tools, and equipment to take and address the potential needs of that system.
Repairers need to be aware of the differences between conventional air conditioning pumps and electric air conditioning pumps.
This is a pretty neat technology that we see, and one of the first hybrids that I saw in a shop with an electric AC pump, I'm looking down there, it's like, where's the belt? And then it came to me, hey, this is an electric pump, cool, So I'm following the orange cable back up to the inverter converter unit, and I'm just kind of looking over the system and how it works, and I got to thinking, wow, this is kind of like my home air conditioning system. It's just got an electric pump to circulate the refrigerant through the system. It's mounted right there on the side of the engine because, well, there's a place there where they've traditionally mounted a pump in the past. What we see on quite a few of the hybrids is that they've got either a purely electric or on some of the Hondas, they've got a combination pump that is both a belt-driven pump with a clutch on it and an electric pump in the same pump housing. Now, I'm going to step back a little further. When the hybrids first hit the market, most of them had traditional AC pumps that ran off of a belt drive, and there was nothing real exotic about that. But very quickly, we saw the transition where they started to move to the electric pumps because the electric pumps are much more efficient so far as energy use. They can run off of a high-voltage battery. With the electric motor technology that's in these pumps running off of high voltage, they have to use what's known as a high dielectric insulation strength oil, which takes and minimizes any chance of stray electric flowing where it shouldn't flow. This becomes something critical when it comes to servicing these systems. So as we take and we get into the AC service with these systems, there's something unique about the oil that we'll see on the next slide. Again, this oil is a high dielectric insulation strength oil, meaning it has very good electrical insulating properties. The vehicle manufacturers do not want you to contaminate these systems with other oils. So this is another one of those areas where we need to make sure we're on top of our service procedures, we're using the right equipment so that we don't contaminate these systems with the incorrect oil. Potentially, it could be a very costly mistake.
And what do the vehicle manufacturers say about using dye in the system?
At first, as we did a lot of research, we saw where most of the vehicle manufacturers said don't do it. What we found is that there are a few vehicle manufacturers that may actually have specific recommendations for a particular product in the system. So this is one where we want to step back for a minute, and we don't want to apply our one-size-fits-all that we've done in the past. It's critical for even the non-hybrid AC systems that we get the right viscosity, the right type of oil in the systems. And in many cases in the past, as an industry, perhaps we've added dye to a lot of the systems we've recharged, just as part of what we do. We really want to step back from that and give that a second thought. We need to evaluate, is there a specific dye? Are we allowed to put a dye in the system? Most of them don't want you to use a dye. So make sure you check the service information. If you do put a die in the system, document what the die was. Make sure you've got the procedure, the product documented, that it's appropriate for that system. That way you're not left hanging, holding the bag on a warranty issue.
I see we've only got about 18 minutes left, and we do want to allow time for questions from our audience. So we're going to run through these last few slides a little bit quicker than normal, starting with some vehicles that use coolant storage or reservoirs to store hot coolant can be susceptible to the collision damage.
Yeah, the 2004 through 2009 Priuses use a coolant storage reservoir that's mounted outside the left front frame rail, and it is in an area that's susceptible to damage on a left front hit. Most of our hybrids have two separate cooling systems, so what it really comes down to is making sure that we understand the procedures to bleed those two cooling systems depending on the service work being done on that vehicle.
And here we see a hybrid vehicle mounted on wheel dollies. What's going on here?
Yeah, the motor generators on many of these vehicles connect directly to the drive wheels. So there is a possibility that we can generate electricity if the vehicle's being pushed. And so potentially this may exhibit a safety concern depending on the service work that's being done. So many of the OEMs, they recommend the use of wheel dollies to avoid any trouble in this area.
And what can you tell us about the future of fuel cell vehicles?
It's probably going to be quite some time before we see mass production on fuel cell vehicles, but much like better than 100 years ago, the Wright brothers and other visionaries conquered flight, look where we are today with being able to travel around the world. It really takes that continual research and development of alternative energy sources in order for us to land on our future.
Okay.
The photo we're seeing here is a fuel cell Chevy Equinox, and I was fortunate enough to be taken for a ride in the vehicle a while back, and it was a really enjoyable experience. I appreciate the folks that afforded me that opportunity. They handed me the keys and said, "Jeff, take it for a ride," and I asked them what it was worth, and I said, "No, you drive me. I'd just like to sit in the back. Thank you very much," and they were kind enough to oblige. When you open the hood on this vehicle, you have to ask yourself a question. Are you going to be ready to ride it, work on it? Are your technicians going to be ready to address it? It's important that we as an industry continue to further our knowledge and skills to provide a complete and safe repair today and into the future.
And is hydrogen a potential vehicle fuel source?
Time will tell. Well, there's a lot of controversy in this area. Not too sure where that's going to end up. If I was an investor and a speculator, I can't say as I'd advise anyone one way or the other. But there's a lot of potential there. And with some of the concerns that we have are, pressures of up to 10,000 psi in hydrogen storage tanks. They're doing a lot of testing and evaluation. There's a few of these vehicles out in test bed operation, and they've got plenty of onboard technology to keep the vehicle safe in case of any type of system malfunction or breach in the system. But we'll see. We'll see where that goes.
Thank you, Jeff. At this point, we'd like to take the opportunity to solicit questions from our viewers. If you have a question to ask, simply type it up and send it to us through the electronic channel provided. We also want everybody to know that if you'd like to view this webcast again or perhaps share it with somebody who is unable to participate today, this webcast is archived at www.abrn.com/hybrids. Once again, that's www.abrn.com/hybrids. Thanks, everybody, for participating, and thanks once again to our sponsor, Mitchell International. Jeff, do you have any final thoughts here before we undertake the questions?
Yeah, I'd like to extend my thanks to Auto Body Repair News, Mitchell, and all of our listeners and viewers. And a special thank you to Jeff Poole, iCar Performance Training Coordinator, for sharing his knowledge about hybrid vehicle repairs. Please stay tuned now for the question and answer session with Jeff. Our first question up, Jeff, is do I always have to disable the high voltage? It really depends on the work that you're doing on the vehicle. I have to kind of step back and this is an area where I know that personally I can't afford to buy any of the technologies that are on these vehicles because I didn't follow a prudent safety procedure. So as we start getting into the repairs, what are you doing to the car? Typically, if you're doing any type of electric welding and things of that nature, you're going to find most vehicle manufacturers want these vehicles powered down. And so we're going to make sure that we follow those procedures. What I always tell folks is it's best to document it, print the procedure out, have it with the prepare order file. That way you can support what you're writing on that particular vehicle. Again, there's just too much technology that potentially we can damage on these vehicles. And this goes for even some of the non-hybrids. Comes to safety and preserving the electronics.
What is the life expectancy of a hybrid battery module?
There are probably a pretty good number of some of the original Priuses out there running around right now with their original batteries in there. Many of the vehicle manufacturers have 8-10-year warranties on these batteries. They've refined the technology where they want the driving public to have the confidence, and they're instilling that confidence through those warranty programs that they're not worried about this just being, oh, I bought this car and 2 years later, it's not going to be any good. So they've got a pretty impressive track record at this point in time, and I expect that's going to continue.
Should a car be down before the use of a 110-volt dent puller is used?
Typically, yes. Again, check with the vehicle manufacturer for specific recommendations, but I think you're going to find most vehicle manufacturers want you to take and power the vehicle down.
And can you tell us if there are any memory loss issues or concerns when disconnecting the batteries?
We're always going to have that on today's vehicles. That's something that we contend with even on the non-hybrids. When we start powering down the computers, they start losing their learned memories, their adapted memories, and we potentially have some reprogramming that may have to take place. We may have some test drive scenarios we have to take the vehicle and put it through before it relearns certain things. So again, this is an area where a case-by-case basis and the correct information to support what we need to do to the vehicle are critical.
Is it okay to jump hybrid vehicles, or will that result in shock or electrical component damage?
That's a really good question there, and this is where we have to step back and we need to know a little bit more about the vehicle we're dealing with. Your Hondas, for example, have 12-volt starter motors on board, and so that 12-volt starter motor allows it to start the internal combustion engine using a traditional starter motor type setup. So there, if the 12-volt battery is dead per se, we can jump start that 12-volt battery following the correct procedures. Now, let's take a look at perhaps the Toyotas. The Toyotas use the high voltage battery to crank the starter motor, if you will, because they don't have a traditional 12-volt starter motor. So therein lies the question, which battery is dead? Is it the 12-volt battery? Then we can just use a traditional 12-volt jump start type scenario, or is it there's an issue with the high voltage battery? Now, I can say that to the best of my knowledge, there's been very, very few incidences where there's been an issue with a high voltage battery in a Toyota type product.
Should a technician with a pacemaker or a defibrillator need to be aware of certain things during the repair, or not being near someone repairing a hybrid? I
am not a medical expert in this area, and I would have to refer that they talk with their doctor about working around high voltage and things of that nature. I think that they would have a bigger concern about working in a body shop, working around welding equipment and resistance welders and MIG welders and things of that nature. So I would definitely refer them to a medical professional and have them evaluate their situation and what they're going to be working around before they really start to venture into this area.
Going back to the spray booth temperature, if the battery does not experience any loss of power at that time, how can the customer go back to the shop a month later and inform them of their concerns? And can the loss of power be tracked back to the shop due to improper temperatures?
That's a really intriguing question there. And I don't know what the technologies are in each of the batteries. I don't know if they've got temperature indicators in there that would take and flag something of that nature. From a stance of documenting your repairs, some of the vehicle manufacturers have the ability to run diagnostics on the batteries and determine what the state of charge and I want to say the health of the battery is. Are we going to get to a point where we're doing that on a vehicle before it goes into the booth, and then we're doing that after it comes out? For the most part, documenting the temperature of your booth, what you've exposed the vehicle to, should generally suffice to cover us. But again, this is another area that I have not had too much experience in yet.
If you remove the cell in a hybrid vehicle, can you still use the engine, or will it try to charge the hybrid cell?
I'll step back and I'll say any technician that's taking hybrid components off of this vehicle should have the training to support the operations he's doing on that vehicle. For somebody that's not trained on that vehicle to be taking these components apart and taking the battery packs out, the inverters apart, connectors and wiring out of the vehicle, that really starts to concern me to a great degree. So I have to say I'm hopeful that folks that are going down that path have the training necessary, have the tools and equipment necessary. Once that vehicle's apart, you're not powering anything up on it. You shouldn't be.
Are there test procedures to determine if a high voltage battery is bad during an estimate inspection to determine repairability versus total loss?
This is another one of the areas where if you've got the right tools and equipment, sure. But if you don't have the right tools and equipment, we're still kind of flying blind.
Okay. Can an HV battery pack be charged using a battery charger?
To the best of my knowledge, there is very limited capability of doing something of that nature. You'll find that most of the OEM information states that if you've got a high voltage battery that's not up to par and not performing, that battery is going to get swapped out. Now, hopefully, if there's someone out there that knows different, they'll be able to provide some feedback to us. But to the best of my knowledge at this point in time, we don't have high voltage battery chargers sitting on the shelf.
A two-mode hybrid is still a mild hybrid, but it seems they are getting a lot of press. What's new with this over older mild hybrids?
I'd have to, for this particular question, I'd have to know specifically what vehicle are we referencing to what's different about it, because what we're seeing is that different folks have different flair or twists on a piece of gum. I hate to put it in that type of context, but there's different flavor gum out there, and maybe it has a little different flavor, a little different texture. So without knowing more specifics about the exact vehicle, I really couldn't answer that.
Toyota states that if welding within 12 inches from the battery, the battery has to be removed. If the distance is greater, can it stay in? And do you know if that's the general consensus from other OEMs? That is that if you're welding within 12 inches of the battery, it has to be removed.
This is an area where I don't know all the specifics for every vehicle manufacturer that's out there. There are some generalizations out there. I would definitely look to print out the specific recommendations for each vehicle that I'm working on at that point in time. That way we're supporting that vehicle, that make, model, and year with the correct procedures to the technician and the paperwork, documentation, et cetera, so that we are working safe and we're justifying what we're doing.
Here's another question on the spray booth. Batteries, as we said, may be affected by high heat in the spray booth. Should we remove a battery even if the damages are not in the area of the battery when spraying?
I wouldn't take anything off of these vehicles I didn't have to. With that said, making sure your booth temperature does not exceed the recommendations, making sure that battery temperature does not exceed the allowances per the vehicle manufacturer, leave the battery in. If you're working close to that battery and you're showering sparks on it, you're replacing a frame rail, you're replacing a floor, then you're working in close proximity to the battery, then we're looking at a situation where we're probably going to take the battery out. But your typical booth type scenario, we don't have to worry too much about taking the batteries out as long as we're keeping that temperature in check.
Okay, we've got 2 or 3 minutes here left, and we're going to just ask a couple more questions. There seems to be confusion as to if the brakes themselves have anything to do with HEV vehicles. I know the kinetic energy of the motor assists in charging the battery, but is there anything different with the ABS system in relation to a hybrid vehicle?
The basic function of the anti-lock brake system is similar to what we deal with on non-hybrid vehicles. But what they've done in many cases is, and I've read through quite a few of the documents that go over the operation of the hybrid systems and the braking systems and regenerative braking. And depending on the vehicle, we may find that in some cases they use the ABS system to really develop our power braking. In other cases, they don't. They've got a traditional power brake booster. So it's more the cooperative relationship of the systems on board. Whereas I'm driving down the road and I let my foot off the accelerator, the vehicle starts to coast. And at the point where it's coasting, they may start to then introduce the higher level of regenerative braking, where it just starts to slow down a little bit. So it feels like a normal vehicle. And as I start to put my foot on the brake, the hydraulic brakes aren't activated right away. The regenerative braking perhaps comes into a little higher degree, starts generating a little more electricity and slowing us down a little bit. If I push on the brakes a little bit harder, though, now it's getting the command that I want this vehicle to slow down faster, and the drag of the drivetrain just is not going to do it. We need to help with the hydraulic braking system. So then they'll implement the hydraulic braking system to assist. Again, that's kind of a general look at it. Each vehicle manufacturer has their own flair on it and own specific sequence of events.
And our last question, is there any danger to either the car or to the technician in welding body parts on hybrid vehicles?
If you follow the safety procedures, there's absolutely no danger at all.
Thanks very much, Jeff. We appreciate your time and sharing all of your knowledge with us. And thanks to our viewers for tuning in today and spending an hour listening to our webinar, Hybrid Repairs, an Electrifying Topic.
Thank you, Bruce.
Once again to our sponsor, Mitchell. And once again, if you want to review this again or refer to somebody who may want to see it, it's hosted on our website at www.abrn.com/hybrids. Thanks, everybody, and good afternoon.